The distance x in meters covered by a particle at time t in seconds is given as x equals to 2t raised to power 3 minus 3t squared minus 5t plus 8. Find its speed in the 5th seconds, distance covered in the 3rd second, time the particle is momentarily at rest, then acceleration at t equals to 5 seconds. Now, to simplify this question, all we need to do here first is to write out the equation that we have in this question. And what is the equation? The distance is given as 2t raised to power 3 minus 3t squared minus 5t plus 8. That is it. Now, at this point, if you talk about speed, speed is your velocity. Speed is velocity. This is speed or velocity, and that is v is the x over the t. Differentiating x, which is distance, with respect to time. Distance over time gives velocity. So I need to differentiate this equation with respect to time. And while differentiating, remember, in differentiation we use the formula y equals to ax raised to power n, such that when you look for dy over dx, it becomes anx raised to power n minus 1. This a here stands for the coefficient, and this n stands for power. For instance, if you are working with 2t raised to power 3, the coefficient here is 2, which is a, and the power here is 3. So we'll now replace this x with what? By t. We'll replace it by t. So let's proceed to the next page. So if we do that now, if we do that, so you can have the next page, and what we have on the next page is the equation, which is x equals to 2t raised to power 3 minus 3t raised to power 2 minus 5t plus 8. Now we want to differentiate. We want to look for differentiating x with respect to t, and the x over the t is same thing as velocity. So how do we do this? Differentiate this 2t raised to power 3. If I'm going to do that, 2t raised to power 3, note, remember you are working with this divided x equals to a n x raised to power n minus 1. So a here is going to be 2, so let me fix 2. I will have 2. N is your power, which is 3 times 3. Now x here, replace it with t, x becomes t, then power is also 3 minus 1. So if you do that, 2 times 3 will give 6, then you have t, 3 minus 1 gives you 2. Or better still, you can just say, okay, the coefficient multiplied by the power, which is 2 times 3, that will give you 6, then the power, subtract 1 from it, then you have t, 3 minus 1, which will give you 2, still same as this. So we use that here again. 3 times 2 again will give me 6, then you have t, 2 minus 1 will give me 1. So for this other part, which is 5t, for 5t now, a is 5, put a to be 5, times n, this is t raised to power 1, 1, then t, then you have 1 minus 1. So this will give 5t raised to power 0. 5 times 1 is 5, 1 minus 1 is 0. t raised to power 0 here is 1, so you are left with 5 times 1, so which is 5. For this part, you have it as minus 5. Then differentiation of a constant is 0. So therefore the velocity v, which is the speed, is 6t squared minus 6t minus 5. Now we have to look for the speed at the 5th seconds. So speed at the 5th second is going to be what? The speed at the 5th second is, you look for speed when t equals to 5. You look for speed when t is equals to 5 minus speed again when t equals to 4. Fifth, t equals to 5, t equals to 4. So all I need to do now to simplify this is come back to this expression. So anywhere I see t here, I'm going to replace t with 5 first, get the answer, and again anywhere we see t here, we'll replace t again with 4 for this again. Then the answer for v when t is 5, we'll subtract it from velocity when t is 4. So let's go with v when t is 5. From this equation you have 6, then t becomes 5 raised to power 2 minus 6 times 5 minus 5. So that gives us 5 raised to power 2 is 25. So that will give 6 times 5 squared, 25, minus 6 times 5 will give 30, then minus 5. So 6 times 25 will give us 150 minus 30 minus 5. So I'm going to have 150 minus 30 minus 5, and that will give me 115. That is the speed at t equals to 5 meter per second. Settled. Again, we look for speed v when t is 4. So v when t is 4, still this formula. Anywhere you see t here, replace that t with 4. So I'm going to have 6. Now t becomes 4, which is 4 squared, minus 6 times 4, then minus 5. So 4 squared is, that is 4 times 4, 16, minus 6 times 4, 24, then minus 5. 6 times 16 will give you 96. 96 minus 24 minus 5. So I'm going to have 96 minus 24 minus 5, and that will give 67. So the velocity, which is the speed at t equals to 4, is 67 meter per second. Therefore, speed at the 5th seconds, the speed at 5th seconds is going to be the v of 5 when t equals to 5, 115 minus 67, and that will give 115 minus 57, 67. That will give 48 meters per second. Therefore, the speed of the body at the 5th seconds is 48 meters per second. We are through with the first part of the question, which is we are also look for its speed in the 5th seconds. So the speed in its 5th seconds is 48 meters per second. Proceed to the next part. The B aspect of this now is that we should look for the distance covered in the 3rd seconds. So this B, we are looking for distance covered in the 3rd seconds. Distance covered now in the 3rd seconds. So if you are looking for distance covered in the 3rd second, so it's going to be distance covered in the 3rd seconds. It will be distance when t equals to 3 minus distance when t equals to 2, similar to that of velocity. Now the expression for the distance is given directly in the question as x equals to 2t raised to power 3 minus 3t squared minus 5t plus 8. So anywhere we see t here, we just solve this twice, when t equals to 3 and when t equals to 2. So we can do this together. Speed distance in the 3rd seconds as x, which is x when t equals to 3. We first substitute that of t equals to 3 into this equation. So you have 2t t is 3, 3 raised to the power of 3 minus 3, again 3 raised to the power of 2 minus 5 into 3 plus 8. Call this the first equation here. So that is the first equation. The first equation. Then we can now have this as minus again t again x when t is 2. So anywhere we see t here, we replace it with a 2 with 2 raised to power 3 minus 3 with 2 raised to power 2 minus 5 with 2, then plus 8. We close this. So for this first part, x, which is the distance, will be 3 raised to power 3, 3 times 3 times 3, 3 raised to power 3, and that will give you 27. So you have 2 multiplied by 27 minus, this is together, 3 raised to power 3, 3 raised to power 2, 9, 3 times 9, then minus 5 times 3, 15, plus 8. That is for this part. Then minus 2 raised to power 3 is 8, so you are left with 2 times 8 minus 3 times 2 raised to power 2, 4, minus 5 times 2, 10, plus 8. So simplify that. 2 times 27 will give you 54. Now 54, distance in the 30 seconds will be 54 now, minus 3 times 9, which will give you 27, 27 minus 15 plus 8, then minus 2 times 8 here will be 16, minus 12 minus 10 plus 8. So we'll simplify what we have here. If you simplify that, 54 minus 27 minus 15 plus 8, that is going to give us, the first part will be 20, then minus it from the second part, 16 minus 12 minus 10 plus 8, and that will give 2. So 20 minus 2 will give 18, and distance is in meters. So the distance covered in the 30 seconds is 18 meters. So we've answered the other part of the question. We are left with the third part, which is the time the particle is momentarily at rest. We are looking for the time the particle is momentarily at rest. For a particle to be momentarily at rest, that is the speed or velocity, v will be what? 0 for the object to be momentarily at rest. Now recall that speed v, we've got that to be 6t squared minus 6t minus 5. Remember, that was what we substituted value into to get the speed at the 5th second. So in this equation now, all we have to do is to turn this v to 0, because the particle is momentarily at rest. So v will be 0. So 0 here, I'm going to have 6t squared minus 6t minus 5, then v turns to 0. Now this becomes a quadratic equation. Then how do we simplify this? We use the quadratic formula. And what are we looking for here? T, which is going to be minus b plus or minus square root of b squared minus 4ac over 2a. So that means t now will be, if you come back to this equation, this is our b. So b is minus, then the b itself carry minus 6 plus or minus square root of b, that is minus 6 squared minus 4 times a itself is, this is a positive 6 times c is negative 5 minus 5 over 2 times a. 2 times a is positive 6. So this will now give t equals to minus times minus a will give positive plus or minus. So square root of minus 6 squared 36, then minus times minus a minus 4 times minus 5, which will give positive. 4 times 5 is going to be 20, then 20 times 6 120 over 2 times 6, which is 12. So if you continue to simplify, you are going to have t equals to 6 plus or minus, this will give 156 square root of 156 over 12. So what is the square root of 156? 156, that will be, which is equals to 6 plus or minus square root of 156, 12.49 approximately over 12. So this shows two possibilities here. That means t here will be 6 plus 12.49 over 12, or 6 minus 12.49 over 12. The positive value gives the answer for the time. T will now be 6 plus 12.49, 18.49 over 12, or 6 minus 12.49, which is minus 6.49 over 12. If we divide that, 18.49 divided by 12, and that gives t to be positive 1.5408, which is 1.54, or minus 6.49 divided by 12, which is minus 0.5408. So the positive value here gives the answer for the time. So therefore the time taken, or the time when the particle is momentarily at rest, t, when the particle is momentarily at rest, is 1.54 approximately seconds. So at 1.54 seconds the particle is momentarily at rest. You can't have negative time for the particle to be momentarily at rest. So the particle is momentarily at rest when t is 1.54. And the next aspect is we are asked to look for the last question, acceleration at t equals to 5. How do I get acceleration? Just bring your velocity here. Remember that acceleration is what? The dv divided by what? The t, derivative, and dv dt, differentiating velocity with respect to time. So a, now if you differentiate what we have here, is going to be 6 again times 2. We are working with this dv. 6 times 2 will give 12, then with what? T, because 2 minus 1 will give that, minus, when you differentiate 60 it will give you 6, then 5 is a constant, it's good to go. Then we have to look for acceleration when t equals to 5 seconds, meaning anywhere you see t here, replace it with 5. So acceleration is going to be 12 times 5 minus 6. 12 times 5 will give us 60. 60 minus 6, and 60 minus 6 will give 54, and acceleration is in meters per second square. So this is how you determine the acceleration of a body when the body is given the position and the position, which is distance, and then you differentiate the distance to get velocity. Then when you differentiate the velocity, it gives you acceleration.